Now we go for infinite line charge, how to find electric flux density and electric field intensity due to a infinite line charge. Consider an infinite line charge having charge density ρl. ρl is the infinite line charge density. You know line charge. If the charge is distributed over the length of the line, it is the line charge. The charge may be distributed in the form of the line, that is the line charge. Assume that consider an infinite line charge of density ρl. ρl is the line charge density. ρl is line charge density. Line charge density. Line charge density carrying a charge of ρl. Line charge density ρl coulombs per meter lying along z-axis from infinity to minus infinity to plus infinity. That is infinite line charge. What is the electric flux density we are calculating? It is very important. If you understand the Gauss law applied to infinite line charge, you can easily calculate the numerical problems related to infinite line charge, infinite surface charge, infinite differential volume element, like that. For this infinite line charge, the charge is placed in a Gaussian cylinder. Assume that surface, Gaussian surface we have to assume any one, spherical or sphere we can assume. Similarly, in previously we assumed that sphere, now we assume that cylindrical coordinate system we have to take. Consider a sphere of radius, Gaussian surface as sphere. The sphere is laid along z-axis. The sphere is laid along z-axis. The infinite line charge having ρl coulombs per meter lying along z-axis from minus infinity to plus infinity. You can see in this diagram. Assume that it is a xyz direction. Consider the cylinder Gaussian surface and write circular cylinder with z-axis, as its axis is z-axis and radius r. The cylinder radius is r. Now the radius of the cylinder is r. Assume that the cylinder radius is r. Having the charge density is ρl. Now it is the charge laid along z-axis from minus infinity to plus infinity. The charge is located, it is minus infinity to plus infinity. Assume that infinite line charge it is. Consider the infinite line charge along the z-axis. The flux density at any point on the surface is directed radially outwards. Previously also we assumed radially outwards. The length of the cylinder is L. Assume that the length of the cylinder is L. L is the length of the cylinder. It is the cylinder length of the cylinder is L and charge density is ρl. Assume that differential surface is Gaussian surface. That is, assume that a cylindrical coordinate system it is cylinder. The differential surface is ds. It is the ds. And AR is the that is d bar. D bar direction is given by d bar along the surface is d bar, and AR is the unit vector. AR is the unit vector along the direction of d bar. It is the Gaussian surface. Gaussian surface here is cylinder. In spherical coordinate system, what is the ds? Similarly, cylindrical coordinate system, ds can be written as r d phi dz ar. Like that we have to apply. Same principle we are applying. How to apply the Gauss law? Okay, the flux density at any point on the surface is directed radially outwards, that is in the AR direction, according to cylindrical coordinate system. Consider the differential surface area ds. Consider the differential surface area ds as shown in the figure, which is at radial distance r from the line charge. Which is at radial distance r from the line charge. It is the r radial distance. Similarly, radius also it is r from the line charge. The direction to normal to ds is ar. Ar is the direction normal to ds is ar. As the line charge is along z-axis, the charge ekkadundi ikkada, line charge is along the z-axis. There cannot be any component of d bar in z direction. Z direction లో ఎలక్ట్రిక్ ఫ్లక్స్ డెన్సిటీ ఉండదు. ఎందుకంటే ఛార్జ్ వచ్చి z డైరెక్షన్ లో ఉంది. ఛార్జ్ ఎక్కడ ఉంటుందో ఆ డైరెక్షన్ లో ఎలక్ట్రిక్ ఫ్లక్స్ డెన్సిటీ ఉండదు. ఎందుకంటే ఎలక్ట్రిక్ ఫ్లక్స్ ఎప్పుడు నార్మల్ టు ద ఛార్జ్, నార్మల్ టు ద సర్ఫేస్. అంటే ఛార్జ్ z యాక్సిస్ లో ఉంది కదా, జెడ్ యాక్సిస్లో ఉన్నప్పుడు దేర్ విల్ బి ఎనీ డైరెక్షన్, ఏ జెడ్ డైరెక్షన్లో ఏది ఉండదు, అంటే ఛార్జ్ ఇక్కడ ఉన్నప్పుడు. ఇది ఇంపార్టెంట్ పాయింట్ ఇక్కడ. యాజ్ ద లైన్ చార్జ్ అలాంగ్ జెడ్ యాక్సిస్ దెర్ కెనాట్ బి ఎనీ కాంపోనెంట్ ఆఫ్ డి బార్. డి బార్ ఈస్ అలాంగ్ ఏ ఆర్ డైరెక్షన్లో ఉంది, జెడ్ డైరెక్షన్లో ఉండదు. వాట్ ఆర్ ద కోఆర్డినేట్స్ ఫర్ cylindrical coordinate system? What are the coordinates? R, phi, z. R, phi, z are the coordinates. R, phi, z. జెడ్ యాక్సిస్లో ఉంది కాబట్టి ఛార్జ్, ఈ కోఆర్డినేట్స్ ఏముండవు, ఈ కాంపోనెంట్ ఏముండదు. నౌ వీఆర్ అప్లైయింగ్ Gauss law for this. What is Gauss law? Q equal to surface integral d dot ds is the Gauss law. D dot ds. The integration to be evaluated for side surfaces, top surfaces and bottom surfaces. Here the cylinder have side, top, bottom. The integration to be evaluated for all surfaces, top, bottom and side surfaces, left side and right side. Okay, now therefore q equal to side surface integral side d dot ds plus surface integral top d dot ds integration has to be carried out for this. If it is a cylindrical coordinate system, we assumed top is top d dot ds plus surface integral bottom d dot ds. We have to apply all the surfaces, entire surfaces we have to apply the Gauss law. Now d bar has only radial component. D bar can be written as dr ar. Similarly in spherical coordinate system, d bar also can be written as d bar can be written as dr ar, as an only radial component it has. Now in cylindrical coordinate system, what is ds? In cylindrical coordinate system, ds can be written as ds equal to r d phi dz ar. This is the differential surface in spherical coordinate system, where ar is the unit vector normal to the direction. Already we saw in the diagram, differential surface area for cylindrical coordinate system is given by r d phi dz ar. This is the formula. In coordinate system we obtained this formula ds. Now we are applying the Gauss law. Dot product of d dot ds we are carried out. Let us see that. Now we are applying the dot product. The dot product is d dot ds. Therefore d dot ds can be written as, we are applying the differential surface and d bar. D bar can be written as dr ar dot ds bar is r d phi dz ar. This is the dot product we consider. Ar dot ar equal to 1. Since ar dot ar equal to 1, ar dot ar equal to 1, we can write dr r d phi dz. Since ar dot ar equal to 1, we can write dr r d phi dz. Now dr is constant over the surface. Dr is constant over the side surface. We assumed that three integrations. Side surface, it is a constant. Now we are applying for total integration, that is d bar has only radial component and no component along z axis. Charge వచ్చి z axis లో ఉంది కాబట్టి z axis లో no component and minus z also no component. Hence we have to top and bottom also becomes 0 because it's a radially outwards. Now see, d bar has only radial component. It is a radial component and it is z axis లో ఉంది కాబట్టి z axis components also becomes 0 and d bar is constant over the side surfaces. Only we have to consider side surfaces, whereas bottom and top also 0 because the charge is distributed along the z axis. Top and bottom along z axis means top and bottom comes under z axis. Z axis కింద వస్తాయి కాబట్టి టాప్ అండ్ బాటమ్ అక్కడ కూడా 0 అవుతుంది. అంటే ఇంటిగ్రేషన్ ఎలా అప్లై చేస్తున్నాం? The integration of top and bottom d dot ds equal to 0 because the charge is lying along z axis. Top and bottom is 0 because it's a z axis top and bottom. and side surface is constant. Only we have to carry it out for side surfaces. That is, we can therefore top and bottom becomes 0. Integration top d dot ds that equal to bottom d dot ds equal to 0. Because the charge along z-axis kabatti top bottom kinda vache electric flux density components 0 avutayi. Therefore q equal to only side, right side and left side, both sides, that is surface integral side d dot ds. This is the equation finally we obtain. In this we have to substitute d bar and ds, that is side d bar can be written as d dot ds can be written as, this is the d bar dr or d phi dz that we substituted. Now we are applying the limits. What are the limits for sphere that we know previously? Now we go for cylindrical coordinate system. The limits are we are applying for this surface integral totally we are applying. Now if we apply the limits z is 0 to L over the length. How much length is the line charge is infinity to minus infinity to plus infinity it is, and phi equal to 0 to 2 pi, the limits of that one. Already in cylindrical coordinate system lo manam limits cheppam kada. Phi equal to 0 to 2 pi, phi equal to 0 to 2 pi dr or d phi dz, like that we can apply. That equal to if you apply the limits of z equal to 0 to L, this becomes z, integration of dz is z, that is integration over carried out z is z equal to 0 to L, it becomes 0 or dr constants. Now integration of dz becomes z 0 to L, integration of d phi becomes phi 0 to 2 pi. And if you apply the limits for this L, z becomes L and phi becomes 2 pi, 2 pi minus 0, that equal to r dr. It is integration limits are L minus 0. Similarly 2 pi minus 0, if you apply the limits 2 pi minus 0. Finally we obtain q equal to q, it is a q, already we know that q equal to 2 pi r dr L. Now what is dr? Dr we can calculate. From this dr can be written as q by 2 pi L, q by 2 pi L. Now d bar, electric flux density vector d bar is given by dr ar. In cylindrical coordinate system we can give electric flux density vector as dr ar. In r direction it is unit vector, that equal to q, we can substitute dr here, q by 2 pi L, q by 2 pi L ar, q by 2 pi L ar. But q by L is nothing but rho L. Q by L we can write q by L. What is the line charge density? Charge per unit length is known as rho L, or total charge by total length is known as line charge density. We can write q by L as rho L coulombs per meter. Therefore d bar can be written as, we can write this as rho L by 2 pi r 2 pi r ar, where L is the length or r distance, it is 2 pi r ar coulombs per meter square. This is due to electric flux density due to line charge, infinite line charge. And what is the relation between d and e? D equal to epsilon e, or e bar equal to d by epsilon naught. The relation between d and e is e bar equal to d by epsilon. We can calculate e bar also. E bar equal to d by epsilon naught, that equal to, in place of d bar we can substitute rho L by 2 pi r, rho L by 2 pi epsilon naught r it is, because it's a d bar we substituted 2 pi epsilon naught r ar. This is the equation, rho L by 2 pi epsilon naught r AR is the volts per meter. That is the electric field intensity we calculated. This is also result obtained from Coulomb's law. Coulomb's law lo kuda manam electric field intensity due to infinite line charge ku same formula ne vastadi, rho L by 2 pi epsilon naught R. Like that we can apply Gauss law to find D bar and E bar. Previously we go for spherical charge. Now we go for infinite line charge. Again repeat it briefly. Consider an infinite line charge having charge density is rho L and lying along z axis. Along z axis lo undanukunnam. Infinite line charge is along z axis having coulombs per meter rho L. It is minus infinity to plus infinity as shown in figure. Consider the Gaussian surface as right circular cylinder. We can consider sphere also. Already previously we assumed sphere. For that we have to apply rho ds. What is ds of sphere? Spherical coordinate system. We have to apply r square sin theta d theta. We have to apply. Similarly, it is a cylindrical coordinate system. We have to apply ds. Consider the Gaussian surface is right circular cylinder with z-axis as its axis and radius r as shown in figure. The length of the cylinder is L. We assume that length of the cylinder is L. The flux density at any point, electric flux density at any point is directed radially outwards. Charge ila veltunnappudu electric flux density always will be radially outwards. Similarly, we assume that it is radially outwards. If we assume small differential area, surface area. After that, we are applying for total differential surface area. Total surface area can be obtained by integrating ds. Okay. Now, consider the different surface area ds as shown in figure. At a distance r, this distance we assumed as length. Length can be replaced with r. As the line charge along z-axis, there cannot be any component of d bar in z direction. Top and bottom becomes 0. D bar in direction to top and bottom becomes 0. Only sides మాత్రమే ఉంటాయి. అది గుర్తుపెట్టుకోవాలి మెయిన్గా. Now we are applying Gauss law for total surface area, integral surface integral d dot ds is Coulomb's law. Now we are applying Gauss law for total surfaces, top, bottom and side. 3 surfaces we are applying for Gauss law. Therefore Q equal to surface integral side d dot ds plus top d dot ds plus bottom d dot ds. D bar can be written as dr ar and ds in differential surface area, ds in cylindrical coordinate system is r d phi dz ar. Now we are applying the dot product for this. By taking the dot product, d dot ds equal dr ar r d phi dz ar. Now ar dot ar equals 1. That is, therefore we can obtain d dot ds as dr r d phi dz. Now we are applying the top and bottom becomes 0. Hence the integration over the top, integration bottom, it is 0. Hence Q equal to sides only. It is the charge is equal. The side equal to Q equal to surface integral side d dot ds equal to side dr r d phi dz. We can write like that. Now we are applying the limits for these sides. The length z equal to 0 to L and phi equal to 0 to 2 pi. What are the ranges of r, phi, z in cylindrical coordinate system? Already we know that ranges. Now to find the charge Q, we are applying the limits z equal to 0 to L, phi equal to 0 to 2 pi, phi equal to 0 to 2 pi. It is a 0 to 2 pi dr r d phi dz. Now dr r you can make a constants. And integration of z dz is z, limits are 0 to L, and integration of d phi is phi, integral, the limits are 0 to 2 pi. Now r dr, if you substitute upper limit and lower limit, L minus 0, 2 pi minus 0, finally you can obtain Q equal to 2 pi r dr L. That is the total charge. Now dr equal to Q by 2 pi L we obtained, but d bar equal to dr ar, that is the one formula we assumed previously. The electric flux density vector is given by in unit vector also dr ar. Now we substituted dr as q by 2 pi L into AR. That is q by L is known as rho L. We can substitute in place of q by L, that is d bar equal to rho L by 2 pi L. L is nothing but R we assumed previously, the distance at a distance, R is the radius of the cylinder, coulombs per meter. If you calculate d bar, we can calculate also E bar, d by epsilon naught. In place of d we can substitute rho L by 2 pi R into epsilon naught. Therefore rho L by 2 pi epsilon naught or AR volts per meter. In this way we can calculate d bar and E bar by applying Gauss law for infinite line charge. If you apply the Coulomb's law also, you can obtain the same equation, rho L by 2 pi epsilon naught or AR for Coulomb's, by applying Coulomb's law also. It is one of the application to find the Gauss law. This top, bottom and surfaces and side surfaces only the electric flux density direction ఉంటుంది. రిమైనింగ్ టాప్ బాటమ్ బికమ్స్ జీరో. ఎందుకంటే ఛార్జ్ వచ్చి అలాంగ్ జెడ్ యాక్సిస్ అనుకున్నాం. ఇది ఇంపార్టెంట్ మనకు. ఆ లిమిట్స్ ఎలా అప్లై చేయాలి, ఎందుకంటే న్యూమరికల్ ప్రాబ్లం చేసేటప్పుడు మ్యాక్స్వెల్స్ ఫస్ట్ లా డిరైవ్ చేయాలనుకున్నా కూడా d dot ds ఈక్వల్ టు ఫ్రంట్ టు బ్యాక్, రైట్ సైడ్, లెఫ్ట్ సైడ్, బాటమ్, we have to apply d dot ds. That is Coulomb's law, Gauss law we have to apply for different surfaces. Hence where the charge is located, ఆ డైరెక్షన్లో ఎలక్ట్రిక్ ఫ్లక్స్ డెన్సిటీ ఉండదు. అది మనకు ఎక్కువ గుర్తుపెట్టుకోవాలి. నెక్స్ట్ we go for coaxial cable. After that differential volume element.